Okay. Okay, so hopefully this will be an interesting session for you all. What I'll be covering is basically ArcGIS as a comprehensive imagery system. Most of you have probably used ArcGIS mainly for GIS type applications or more vector type applications. You may not realize the full potential that ArcGIS provides for working with imagery, not only a single image, but thousands or millions of images. So this is sort of the agenda. We'll talk about the comprehensive system. I've split it up into sort of 5 areas: content, management, reality mapping, analysis, visualization, and then deployment options. The focus in this session is really going to be on the management and analysis part. So, as an ArcGIS is a comprehensive GIS system, but it also, we break it down into 5 key components for imagery. Content, which is where you're going to get your content from. Where does this imagery come from? Management is how do you manage that imagery if you have it? Reality mapping, specifically for working with imagery from satellites, drones, and aerial imagery to create foundational base maps. Analysis is extracting information from imagery, extracting the locations of roads or other features. And then visualization is really providing that imagery to humans to look at and interpret and come up with their own decisions. So let's start a bit on content. There's a lot of content within ArcGIS that exists, for example, in the Living Atlas. The Living Atlas is available to everybody here. When you go into ArcGIS Online, you basically click on the Living Atlas and you get access to literally petabytes of imagery content that's there. Whether it's Sentinel, Landsat, elevation data, there's huge amounts of data in the Living Atlas that you can directly use. There's also we also work with a lot of different content providers. So there are a lot of partners who collect imagery and make that available, some for free, some for sale. And this is just a list of some of the content providers providing imagery that you can use for visualization analysis. And then many of you probably have your own imagery within your organizations, data that's collected either from satellites, maybe terrain models, classification data, a lot of imagery, maybe it's just street view imagery. Huge amounts of imagery are being collected. So these are sort of the three real sources of imagery. So one thing that's very unique in ArcGIS is the ability to support all different modalities of imagery. When most people think about imagery, you might think about a satellite image that you might see as a base map. But there are so many different types of images. This is just a list of some of them. Things like scanned maps. You may have old maps that you've scanned into the system. You may have scientific data, massive amounts of scientific data available. Digital terrain models are typically, although they're not imagery, we would represent them as images and masters. 3D imagery may be collected by street vehicles, a video. So there are lots of different, what we call modalities of imagery. And ArcGIS is unique in its ability to work with these different images as data sets. Data sets that can be imported into or loaded into the system or accessed by the system directly, as well as web services. So many of these image services are now coming available as over the web. So the typical example is the imagery base map in ArcGIS Online. You just drag and drop it into your applications, be it web or desktop applications, and you can directly view that imagery. Similarly, we have lots of other services to enable access to imagery. So once you have your imagery, you need to manage the imagery. The management of the imagery is where we take the various formats of imagery. So most imagery comes in various formats, typically something like TIFF or JPEG 2000 or JPEG. There are lots of different formats of imagery. ArcGIS supports about 150 different formats. So if there is any imagery that you have, it's extremely likely that ArcGIS directly will work on it. So we can work with the images in different formats, the different modalities that I defined before. We also work with imagery from various sources. So this can be from sensors, imagery coming from satellites, from planes, from drones, from vehicles. So the imagery from these sensors typically has to be somehow processed. You have to take the imagery from a plane and convert it into, for example, an orthophoto or a 3D mesh. We'll be showing you a little bit about how that can be done. The imagery, what's unique about imagery, which is different to vector data, is the volumes of data that you have. Yeah. Although a vector data set may be in maybe megabytes or maybe gigabytes, in imagery we're talking about terabytes and petabytes. Yeah. The data volumes are large. The Sentinel data that's available in the cloud is around 20 petabytes of data. Okay, so it's huge amounts of data. Within your organizations, you may also have large volumes of data. And what's important is that we provide tools to model that or manage that. And these we refer to as optimized data models. So depending on the modality of the data, there are different data models that are used to actually manage that data. I've been talking quite a little bit about mosaic data sets as one of them, but there are other ways of managing the data with last data sets, which are, for example, point clouds and multidimensional CRFs, or very much for scientific data. Once we manage the data, once we have the data, we've modeled it or using one of these data models, we then need to make it accessible. And that's where we actually provide the tools to efficiently stream and share that imagery. So you have the imagery on a server, and you can use it on a desktop application, but you then want to serve it to a large number of users. So you have to take those terabytes of data and stream those over the internet or a network to a user. Obviously, you can't transmit all the data. You need to have the system has to be able to stream only what the end user needs to see. And we have different ways of doing that with image services, either tiled image service, dynamic image services, as well as handling things like voxel layers. So image management, also an aspect that needs to be considered as accessibility to that data. Do you give the imagery access to everybody in your organization or only to certain people within organizations? That again is where ArcGIS Enterprise provides that capability of identity and the ability to share only the content that you want to different users. So image management is important because it really is the basis of other things. If you're not managing your imagery effectively, you can't use it as the basis for reality mapping. You can't really do analysis on it, and you can't visualize the data. So image management is a critical component, and that's why a lot of emphasis is put by both Esri as well as our customers in correctly managing the volumes of data that you have. So why is it important? As I said, that is because there are all the different formats of the data, the scalability of it, being able to scale it as imagery grows. You may only have maybe 100 gigabytes of data at the moment, but over time you're going to get more and more of it. And what you want to do is to make sure that that imagery becomes accessible to everybody within the organization. If it's locked away in a cupboard somewhere, it's basically worthless. If it could be accessed by more people, its value significantly increases. And then if you can actually also use it for analysis, then there's a lot more that you can get out of it. So you really want to efficiently share the data, irrespective of the format and structure of the data. So this is really just showing the different ways of making the imagery accessible at scale. The way we do that for imagery is using a mosaic data set. I talked about the different data models. The primary data model for working with imagery is a mosaic data set. A mosaic data set is really a database model that references the different data sets. So within your organization, you may have thousands or hundreds of thousands of images. You don't want to try and stick them all into a single image. That's not going to work. What you do is you create a mosaic data set. That mosaic data set references all these different data sets, which might be within your network, and defines how they are supposed to be stitched together, how to mosaic the images together, as well as functions to be applied on the images. So you might have, for example, 1,000 Sentinel-2 images, satellite images. But when a user accesses them, they want to see it as a single mosaic. They may want to change the band combinations, have a look at the different band combinations, or perform different types of analysis on it. So instead of working with potentially millions of images, you load those into a Mosaic data set, and then people can work with that single Mosaic data set. That Mosaic data set is used to manage the data. You can author it in ArcGIS Pro, and once you've authored it, you can do various things with it. One is to convert it into back a bit. So there was a pointer. There's no pointer on this one. Okay, so one thing you can do is to convert it into to tile cache. Tile cache is similar to if you go to the world imagery in ArcGIS Online. It's basically a single large image. You pan and zoom around, and it's immediately there. Yeah, that's tile cache. The other one is dynamic image services. Dynamic image services allow you to work with collections of overlapping images, go through time, change different band combinations. So it's designed for large volumes of imagery to be able to look through time. And what's unique about it is that the client application makes requests to the server processes the data and returns the image as required. So instead of just serving a predefined tile, a predefined cache, it allows the client to define how it wants to see the data. We also create, so TPK, what I refer to as TPK, is a tile package. It's for very simple data or simple imagery, just RGB image. What we have in the middle is CRF. CRF is a cloud raster format. It supports tiled imagery, but it supports lots of different bit depths and that number of bands. So in the CRF you can store imagery which is, let's say, 12 bands and 16-bit data. So it allows much richer type of data to be stored. Mosaic data sets can also be multidimensional. So if you think about scientific data, you have X, Y, you might have height, but you might have time and precipitation, or multiple dimensions to the data. So Mosaic data sets can be used to store that data. And that's what's really represented in the bottom part of this model, that these Mosaic data sets can be stored as converted into CRFs, but also multidimensional CRFs. Multidimensional CRF allows you to look very quickly through different aspects of the imagery, through time, but it may create profiles of the imagery. So these data sets can also be directly served in image services, as I said, I'd mentioned the map tiles, the dynamic imagery, as tiled image services, and then also used for raster analytics. So raster analytics is the ability to perform very good scalable analytics on the data. So Mosaic data sets are an important data model. They can be automated. The creation can either be a manual process of going through the tools within ArcGIS Pro to manually create the Mosaic data sets, or to use something we call MDCS. MDCS is a Mosaic data set configuration scripts. It's a way to automate the creation of Mosaic data sets. So MDCS is typically used if every day you have new satellite scenes coming in and you want the system to automatically add them to a Mosaic data set and publish them to your organizations. But typically what you do is you create an MDCS and use MDCS to script that. So typically the best practices for imagery are, or what very often happens is that you get imagery, and that imagery is in a format that is non-optimized. So the data structure of the imagery is important, and one of the best practices is to ensure that you create the data as optimized. By optimized, we mean that we take the images and internally to the format, we cut it up into into tiles, and we create pyramids. And that means that the system can access the data. Remember, there's massive amounts of data, and if a client application wants to only read a small part of it, you don't want to transmit the whole image. What you really want to do is to ensure that the system can very quickly extract only the images that you actually need for your analysis or visualization and transmits that. And that's the key aspect of optimizing the image format. Within ArcGIS, we provide all the tools to optimize the imagery, and typically it's stored as CRF, COG, MRF, or CRF. So COG is Cloud Optimized GeoTIFF. It has become very popular in the last, let's say, 5 to 10 years. It's really a flavor of TIFF, which many people, but it ensures the data has a pyramids, and has these tiles to enable fast access. There's also MRF, is a slightly more optimized format, specifically when working in different cloud environments, mainly to do with how the caching is done internally. And then CRF is a format, also cloud optimized, designed for very, very large data sets. So if you have a single data set that's maybe in the hundreds of gigabytes in size or a terabyte in size, you can't put that into a TIFF file. You can use a CRF as a cloud raster format. Its big advantage is that you can read and write on multiple computers at the same time. If you have a big TIFF file and you have 3 computers trying to write it and read it or write it at the same time, it's not going to work. With CRF, you can have these very, very big files and write the data simultaneously. So you might, for example, have a terrain model of your whole country, and you have different processes wanting to read and write it. That is really where CRF has an advantage. So in summary, if you have images, before you try and serve it, do look to see that it's been optimized, because most of the issues that people have in saying the system is slow, it's because the data has not been optimized prior to trying to serve the data. This slide is really to highlight 2 aspects of how images are accessed by client applications. One is tiled imagery, and the second is dynamic imagery. And it's good to understand the difference between the 2. So if you look at a base map and you pan and zoom around, you have a very what's called slippy experience. As you move, you see tiles. If you carefully, you'll see little tiles come up because the data has been cut up into lots of little tiles. And as you pan, you just add some more tiles and the other ones disappear. Okay. So what happens if you zoom into an area, the system works out which tiles are required for that area and transmits only those tiles back to the client application. And that's what's being shown up here. So this is my whole image, and this is my request. It basically works out it's going to send 4 images back to you. That's great, but those images, that's one way of doing it. The other way is by dynamic imagery. By dynamic imagery, the client makes a request. The server accesses those 4 images and then sends you 1 image back. So it basically does the processing on the server and transmits the resulting image back. That also has advantages because there is a single request that goes to the server and a single request that comes back. And the request that comes back has been compressed and optimized to what the user sees. So less data is being transferred across the network. Yeah? So in one, you have many little requests going backwards and forwards, but it can be cached very easily by the client side. In the second method, you have a single request going backwards and forwards, and there's no point caching on the client side because it was created specifically for the screen. So these are 2 different types of data access. ArcGIS supports both of them. Each has advantages and disadvantages, depending on what you're trying to do. So I mentioned mosaic data sets, but that's not the only data model. There are other data models that are available within ArcGIS, depending on the type of data that you're actually working with. One is a trajectory data set. I don't know if we have much in the Middle East trajectory data set, but it comes very, very often from scientific satellites, which are recording, for example, elevation data from space. So this was very often called satellite altimetry. That's represented by, it's managed using trajectory data sets. Oriented imagery is typically street view imagery or drone imagery. Imagery from cameras, could be security cameras, could be cameras from a drone. So these are images where you typically don't merge them together, you see them individually. So those are oblique images managed using what's called an oriented imagery data set. Last data set is for LiDAR data. So although LiDAR is not really imagery, it's still a source of data, remote sensing data, and it's typically handled as LAS files, and we have what's called a LAS data set, which is used to manage that. And then we also have a catalog data set. It's another way of managing all different types of layers within ArcGIS. Imagery is a layer within ArcGIS, although, you have lots of different types of many different layers within ArcGIS. But a catalog layer is a way of managing many of these different layers together to create a single layer. It's a bit like a group of layers, but the system automatically loads the correct layer as you pan and zoom around. So these are different data models that can be used to manage imagery. So to do the image management, we typically use ArcGIS Pro. So ArcGIS Pro supports, if you have ArcGIS Pro on a desktop, you can read all the different formats. You can author to create the mosaic data sets, generate these tile caches, multi-dimensional CRFs, these optimized data formats. You can then publish them to either ArcGIS server or ArcGIS Enterprise, or publish them to ArcGIS Online, dedicated. I'll come back to that later. And within ArcGIS Pro, you can also directly perform analysis. And we'll be talking a little bit about that a little later as well. So serving the data, we do that through ArcGIS Image Server. ArcGIS Image Server is basically a component of ArcGIS Enterprise. If you have ArcGIS Enterprise, you can get ArcGIS Image Server, and that then performs imagery or tiled imagery. And so we sometimes refer to as on the fly processing of the data. So the server is actually processing data as it's being accessed and generating the different products, which can be accessed by web application, desktop applications, or different devices. ArcGIS Image Server is also the foundation used for raster analytics. So raster analytics is used for the scalable analysis of scalable analysis of data. When I talk about a little bit more about scaling imagery analysis, I'll talk a lot more about raster analytics and its ability to process data at scale. But yes, key thing is that you manage the data typically in ArcGIS Pro, and then you serve it through ArcGIS Image Server, which serves the data as well as performs the analysis on it. So we talked a little bit about management. Let's go on to another aspect, which is reality mapping. Reality mapping is what people like watching. Yeah, it's taking imagery, typically from satellites, from drones, from planes, and converting it into reality, realistic 3D representations of the world. And these are accurate base maps that you can show in a 3D environment and superimpose with different vector data. So they're extremely accurate. You can create these environments where people can pan and zoom around in 3D. You can superimpose. So you see this building is actually a model of the building. It's not actually, you've actually superimposed a building into the 3D environment. So it creates an environment which is very intuitive for people to understand the spatial relationship between things. It's going from a 2D into a 3D environment. So for a lot of information systems, this 3D representation is very, very useful. So how is it actually created? Well, it can be created from satellites, planes, drones, and even higher resolution imagery. So what's really good about ArcGIS with the reality products is that we support the whole range of sensors. So you see here some of those different samples. Some of this data model, some of these data can be, let's say, models. Models are typically very detailed representations of a particular aspect. It could be a radar dome or something like that, where you want a real accurate representation of it down to the centimeter or millimeter resolution can be represented in these models, typically of a small area. And you might have also other reality models which cover large regions. It can be a whole country or a whole city can be represented. And what ArcGIS can do is to mix these different models. So as you zoom into the radar dome, you have the details down to the millimeter level, and as you zoom out, you can have details covering very broad areas. So within ArcGIS, we can manage the assets all the way to countries using the same technology. Just as an example, just the sort of resolutions, and very often when people fly the data, they typically ask, what is the resolution that we need to fly the imagery at? This is giving you some examples of the sort of details that are available with 10 centimeter pixels, 5 centimeter pixels, and 2.5 centimeter pixels. You can see the level of detail is increasing, that is increasing, and you have to decide what level is appropriate for your application. Obviously, it gets more and more expensive depending on how the resolution that you need. You need to work out what resolution is appropriate for your needs. This, for example, is a sample from satellite imagery. It's a new capability within ArcGIS to take satellite imagery. I think This might be PTI as NEO data. So it's 30 centimeter satellite data, which can be collected literally anywhere in the world and processed to create these 3D representations that are GIS ready. So this is just showing how it can be overlaid on your GIS data to bring out a lot more information from the data, and how it can then be used for different types of analysis. So here, looking at a center line of a road, but in a second they will actually show. This is an ArcGIS Pro showing how we can do line of sight analysis. So pick a point and see what can be seen by the application. Obviously, there are applications in security for this, but also telephone planning, things like that, being able to do this viewshed analysis. So analysis on 3D data becomes important. It really takes everything to, well, no pun intended, a new dimension. Gives you abilities to not only visualize, but also determine things that you would not be able to determine from 2D data. So these, what we call true orthophotos and 3D meshes, can be used to perform lots of different analysis. What's also possible with data is that it's what's called watertight. What that means is that there are no gaps in the data. These can actually be used for different types of modeling. So it's actually taking that data and modeling it in ArcGIS Pro to see how, for example, a flood would occur within a city. Yeah, what areas that would be flooded. So it's actually modeling the water and how the water interacts with the surfaces that are surfaces as well. So this is a very advanced type of analysis available when these type of data sets are used. So that was really about reality, but let's talk more about actual analysis within ArcGIS. So the analysis is really extracting information from imagery. It's obviously used in many different industries. State and local government use analysis, public safety, transportation, utilities, defense and intel, obviously a massive user of it, natural resources. All these are industries that have assets that they need to monitor, they need to model and extract information from. And imagery is really the source by which the vast majority of this information is obtained from. It can be a very lengthy process to extract information from imagery, or it traditionally was, because people would have to interpret the imagery. You'd have to have somebody go through the imagery and pick all the planes, pick the location of all the manholes, pick the location of all these different things. There used to be huge teams collecting this type of data in all these different industries, and that is basically changing. And the analysis can be used to solve a lot of problems. Tracking of activities, what changed when. Yeah, I'd mentioned the creation of content, for example, the reality meshes that I'd shown before. But detecting risks, detecting change, and is probably one of the biggest uses of imagery analysis is what has changed within on the ground. Yeah, if you have an old image and a new image, we can then use that to determine what has changed. So there are a lot of tools or features within ArcGIS for extraction from both imagery, from 3D and video. So this is really showing the different types of sources that we can extract information from. 3D scenes, I was showing that before. Motion imagery, so if you have images from a video source, it could be a drone, it could be a security type cameras, we can extract information from that. From 3D point cloud, which is things like LiDAR data, from overhead or top-down imagery, from time series data. So a lot of these data sets are collected multiple times, and the temporal component, the fact that we see things at different points in time, is very, very important to enable this type of extraction. I mentioned oriented imagery. This is sort of street view imagery, and then also imagery collected in the field. So these are all different types of images that we want to extract information from. And this is really a list of the different types of analysis that can be performed. Things like change detection, multidimensional analysis, looking at looking at multi-dimensional data. Spectral analysis is looking at the bands in the data. Things like Sentinel have many bands, and we want to extract information like crop health from it. Image classification, machine learning. So these are all the different, the list of different tools that are available. ArcGIS has literally hundreds of tools for extracting information from imagery. Even things like hydrological modeling. I showed that, remember the analysis of the water flooding analysis. That's a typical example of that. What's becoming very popular, mind you, is the application of artificial intelligence for the feature extraction. Just like our brains can extract information from images, so computers can now be taught similar concepts of how to use neural networks and to extract information from imagery. So these neural networks or AI are typically quite complicated to run because there are so many of them, and there's so many different things that you actually want to run. What Esri's been doing over the last years is to really make it simplified on how you can run different types of AI on these images. So how to extract, for example, the location of water, how to extract buildings, location of objects, count objects. So there are lots of different ways that ArcGIS can be used for working with the data. So this empowers users to do these workflows, to take the data from these different industries, apply these GeoAI workflows to the different types of data. This is typically in what we call the GeoAI workflow. So the workflow goes from left to right. I'd mentioned the management of the imagery. Typically, you have to label the imagery, you have to prepare it, you have to train the models. This training aspect can take a lot of time. Typically requires a pretty large CPU computer with CPU that can run for hours or days to train the models. Once you have the trained models, you can use inferencing, which is really that aspect of taking that model, pointing it at an image, and then using that to extract or derive the different information. So many, many different models that are available. So ArcGIS works with literally any type of AI that you find in the market is available and integrated within ArcGIS. I'd mentioned the training of the models. This can be extremely costly and time-consuming to create. What Esri has done is to create pre-trained models. These are models that Esri has already computed for you. You can see all different types of them for extracting buildings and roads and transmission lines and things like that. So what Esri's done is collected large amounts of sample data, done the training or labeled the data, trained the data, and then created these models that you can directly use within your application. So if you have imagery and you have a particular type of data you want to extract, you can just go and use these models. Will they be 100%? No. It will be good, but not excellent. But the key aspect is that if there are mistakes in it, you can now go and retrain those models, and you start at a much higher level. Instead of training it from zero, you have a model that works, and you can then extend that model and improve that model with your own data sets. One way to do that is to use Deep Learning Studio. So Deep Learning Studio is the ability to manage how do you train it. If you have data that you need to collect and label, Deep Learning Studio is how an enterprise would actually manage that data. How do you get potentially hundreds of people to label, let's say, manholes or water transmission cables or something like that, and use that data to retrain the data. So Kanan, do you want to give a quick demo of?
Sure. Thanks, Peter. Yeah, I'll go. So talking about Deep Learning Studio, I'm just going to show a demo of a high resolution, a drone imagery, where we are going to collect objects, basically the buildings, and then how we are going to export this as a layer for our analysis. So that's what we are going to show. Yeah. I'll just... So considering the time, we are already pre-run setup of Deep Learning Studio that we have worked on. So I'm just going to kickstart that. Before that, let me just make sure I'm ready with my data sets. So as Peter explained, Deep Learning Studio is a web application with ArcGIS Image Server. We just create a project wherein we are going to do an object detection. So to do an object detection, we have to make sure that we train the system or we train the application. So here what I'm going to do is I'm going to take an TIFF image, and then I'm going to label it. The first process is labeling the imageries or capturing the information what I want to do. This can be helpful, for example, as a part of crisis management. Okay, what I'm going to do is I'm going to capture a few buildings as samples and tell the system that, okay, these are the buildings that you are going to take it as a sample and capture me all the other buildings in this area. So here, from the traditional classification, pixel classification, what we are going to do is we are going to group the pixels and make it as an object. You see that? So now it has already divided those images into multiple grids. Basically, one of the team member can work on one grid, other team member can work on other grids. So they can have a multiple level of detailing, and they can have multiple level of data capture as part of the labeling. So we are just going to do these labeling aspects. So now this is the way that we are going to capture it. Now this will be helpful for you. For example, let's say there is a fire. How many buildings are being destroyed, or how many buildings are safe? You want to do some kind of an analysis. Then this will be helpful for you to identify those buildings, damaged buildings and the fire buildings. So there are a lot of ways that you can do it. Once you label it, you're going to export these labels, and these labels will be given as a part of a training samples to the system. So the deep learning understands, okay, Kannan has given me some of the labels labeled as the buildings itself, and then I'm going to understand, okay, these are the building structures, these are the geometries that I'm going to capture in the whole image. So once I have it, I'm going to train this model. So there are a lot of training models that are available from Esri. So you can use these models. So you have to choose model type that you have it. So you can detect, here I'm using a SSD, single shot detector models. I'm going to make the system learn using this model. Once it learns it, it runs the analysis and it shows, okay, what is the training and what is the validation. And finally, I run through the inference, which means I'm not going to use the same imagery, but I'm going to use the nearby imagery to make sure how much accuracy I'm going to get into this. And finally, what output I get is the buildings that are being extracted. It's going to take some time for me. I'll leave it to you, Peter, to continue with the presentation. We'll show the results a little later. I'm just going back to the presentation. Yes, Peter, over to you.
Okay, so a quick thing about AI Studio. Next area I want to cover is the visualization. As I said, in the five aspects of the comprehensive imagery system, visualization is about how we make that imagery accessible to users. And there are lots of different ways within ArcGIS. ArcGIS Pro is probably the most well-known interface for working with imagery. It works with different types of multispectral data. It also has the capability of showing stereo imagery, motion imagery, working what we call image space, which is like instead of working in a map space, you work in image space. But we have other applications as well. ArcGIS Excalibur is a great tool, typically used for what's called SOMS, Structured Observation Management. If you have a lot of images and you're looking for, let's say, all the planes, where are all the planes? And you want to label them and you want to extract information of them. Excalibur is a great application for enabling many people to work with this type of imagery. There are other applications, web applications that can be written in multiple ways using, for example, the JavaScript API. There are configurable templates, web app builders, and experience builders, as well as oriented imagery. So these are a multitude of different ways that imagery can be made accessible to users to make informed decisions. So it's really the human interpretation of imagery in desktop, web, and mobile applications. On the website, we want to do this visualization. There are three key methods. Experience Builder. Experience Builder is a sort of low-code, no-code way of creating applications. So you can create a great web application by literally using an interface to drag and drop these widgets. You can configure the widgets and then directly create applications that work with imagery very easily. You can also extend it with additional development if you want. Instant apps are even simpler applications that are sort of pre-created that for doing different things within the GIS, and there are some instant apps specifically for imagery. And then dashboards is another way of very often taking the results, very often deep learning, and representing it as a dashboard within your organization, so you can see. Executives can very quickly understand what is going on. So this is just again summarizing the instant apps, the experience builder, and the dashboards, what they're really focused on. So as I mentioned, the instant app was for very simple things like doing searching for imagery, doing things like swipe. The experience builder it's still very simple to set up, but it allows more advanced applications, and then the dashboards are these very simplistic ways of looking at the data. There are also more advanced ways of working with the imagery using the APIs. So we provide different APIs. There's a Pythonic APIs. So those who like working with Python and developing in Python can use the Python APIs. There's the web tier, which is more using things like JavaScript to access the imagery. And then within ArcGIS Pro, we can actually ArcGIS Pro has huge amounts of imagery capabilities, and that can also be programmed as required. Many organizations are using the Python API. This can be utilized to perform analytics on the imagery. Typically, it's especially if the imagery is being accessed by a server, those servers perform the processing required, and the developer could create the use of Python APIs to access the imagery and get the servers to perform different types of analysis. So doing classification or interpolation, all sorts of analysis can be performed by using these Python APIs. Notebooks are also very popular as a way of developing and documenting imagery workflows. So especially the more scientific communities very often frequently use Python notebooks within ArcGIS, and you can sort of document your workflows and publish those so others can follow the same processes, potentially replace the data sources with their own data sources, and go through how performing the different types of analysis. So you create these Python notebooks, you can then share them to people who can then pick them up, modify them, and then run them easily. So image management, the image management analysis at scale. We've talked about how the data can be acquired, a little bit about how it's stored, how we can process the data, how we can share the data, and create the different products that can then be visualized and analyzed. So it really is a flow of getting the imagery from its source to the end user as a person or a computer. So how does that done? How can one do that in ArcGIS? Well, there are actually four different deployment patterns that can be used. They all are capable of working with imagery, but each deployment pattern may be more optimum for certain areas. The first, the desktop. Okay, the desktop deployment pattern is utilizing your laptop or a large workstation computer. You can run ArcGIS Pro and perform all types of analysis. So ArcGIS Pro is a phenomenal tool for authoring the imagery, for example, creating mosaic data sets from these different sources. So you can manage the data with ArcGIS Pro. You can then publish it if you want to ArcGIS Enterprise, online, or image dedicated. I'll come back to that in a minute. Or you can perform different types of analysis. So ArcGIS Pro has every type of analysis that's available within ArcGIS is available with ArcGIS Pro. So it's incredibly rich in its ability for doing different types of analysis and can be scaled, but it's scaled vertically. What I mean by that is if you have a machine and you want to run faster, well, you get a bigger machine with more memory, more CPU, and you can scale that way. Okay, so that's one way to scale. It is more limited than the other methods, but it is incredibly capable. Anything you ever wanted to do in imagery is probably going to be in ArcGIS Pro. That's one way of one deployment pattern, as I said. The other deployment pattern is to use ArcGIS Enterprise. So ArcGIS Enterprise is where organizations have typically their own infrastructure, which is on-premise or in the cloud, and they want to set up an imagery system typically to serve and process, serve data to large numbers of people and perform large amounts of processing. So you set it up within your organization, this ArcGIS Enterprise, and you add ArcGIS Image Server to it. So again, the authoring for Enterprise can not only be from ArcGIS Pro, but you can use other aspects such as notebooks and the Pythonic API to author the data which goes into ArcGIS Pro, into ArcGIS Enterprise, sorry. Once it's served in ArcGIS Enterprise, once it's stored in ArcGIS Enterprise, it can be either what we call hosted or by reference. So hosted means that you actually load the imagery into ArcGIS Enterprise, and by reference means that ArcGIS Enterprise is pointing to the imagery. Both methods are available, and you can then use that to serve dynamic imagery or tiled imagery. And then ArcGIS Enterprise with Image Server also performs the RAST analytics. So, for example, running that deep learning training or the inferencing on large amounts of data, you could use RAST analytics to do that and spread that over multiple machines. So Enterprise, whilst Pro is running on a single machine, ArcGIS Enterprise can run on multiple machines. We came out recently with ArcGIS Enterprise with image services for Kubernetes. This is actually using the power of Kubernetes to enable distributed processing of the data over multiple machines or cores. It's a very, very powerful way of scaling up the different types of analysis. So you take your data, you have it either hosted within ArcGIS Enterprise or referenced by ArcGIS Enterprise, and then you can set up these processes which run and extract the information from imagery potentially very rapidly. So this is just an example of taking a 2 trillion pixel data sets, actually nape imagery in the US, and then doing land cover classification. So classifying all these pixels. It's typically now done with AI. Traditionally, it was done with more standard classification methods. Now it's done with AI. And you can see how by just increasing the number of CPUs and GPUs, the performance can be substantially reduced. So going from 2 machines to 3 machines, we've actually gone literally halved the time it takes for doing this massive amount of processing. So as you scale up with more machines, the processing time comes down. Briefly about the ArcGIS Online. So ArcGIS Online is a SaaS, a software as a service. As a SaaS, you don't have to install anything. You can upload and host your imagery in ArcGIS Online and then get access to it. So in this case, you can do the authoring from ArcGIS Pro or directly in ArcGIS Online or notebooks. You publish the data, you push the data into ArcGIS Online. You see it as hosted image services. So in other words, the data is being loaded into ArcGIS Online. Once it's in ArcGIS Online, you can perform a wide range of analytics. So anybody who's got ArcGIS Online and has a professional license, this is now available to them. Previously, it was a separate extension. About a year ago, we changed this to anybody with a professional license can actually access these imagery capabilities within ArcGIS Online. So there are a number of new capabilities. We're always enhancing it. But the key thing here is if you don't need, in ArcGIS Online as a SaaS, you don't need infrastructure. Take your imagery, you upload it into ArcGIS Online, and then you get these capabilities of doing this type of analysis. Even all the AI-based learning inferencing application capabilities are available in ArcGIS Online. The fourth deployment method is image dedicated. So image dedicated is a way of running ArcGIS. If you want to have the data in the cloud, but you don't want to actually manage the infrastructure in the cloud. So these very large data sets exist. Some of them already exist in the cloud. For example, the Microsoft Planetary Computer has petabytes of imagery data sitting there. There are other public clouds with data. You may have content from partners. You may have a satellite provider who has content in the cloud. You don't want to download it. What you can do is to set up ArcGIS Image Dedicated. So ArcGIS Image Dedicated is available in AWS or any AWS or Azure region. And the key aspect is it's about moving the processing to the data. Instead of downloading the data into your organization, you move the processing to where the data is. Esri will actually manage the infrastructure, so the servers. We spin up the servers for you on demand next to the data and perform different types of analysis and serving of the data. So we can serve the data as tiled imagery or dynamic imagery, or provide various types of processing and analysis, for example, running AI models. It's also possible to run ArcGIS Pro, that desktop that I mentioned before, within that region. So, for example, if you're interested in working with the Microsoft Tanager computer data, you can upload, you can get a license of, subscription to Image Dedicated, spin up ArcGIS Pro next to that data, define the modeling that you want to do, and then scale it up with the processing analysis capabilities. And we can massively scale the processing and analysis to be performed. So in Image Dedicated, the authoring is typically done with an ArcGIS Pro. You reference the data, so it's not hosted. We reference the data. The servers are pointing to where the data is, preferably running those servers, the processing in the same location as the services. And then you can perform different types of processing on the data, with their outputs either being served as new services or written to cloud storage. So, which deployment is best? Well, it depends on your needs. So this is a summary of the 4 different ways of doing it: desktop, ArcGIS Pro, ArcGIS Image Server, Enterprise, SaaS with ArcGIS Online or Image Dedicated. Each one has its advantages, and in many organizations actually would use a hybrid approach. So very often organizations actually use a combination of online and Image Dedicated is a very common use case, but many organizations utilize multiple of these deployment options for their data. So I've been covered a lot. It's a very, very large subject, working with imagery.
Maybe the floor for some questions.
Yeah, so this is just a website that you can go to, which also has a lot more information. So yeah, maybe do you want to go show the results, and in the meantime we can see if there are any questions.
So we leave the floor for the Q&As.